First of all, thank you very much for people who talked before me. Some fantastic talks. There's no way I can live up to that, but I'll try my best, okay? So, let's do this. So my name is Irakli. I work at the API Academy with Ronnie. And I focus on systems engineering, distributed systems, a lot of API research, things like that. And it's no secret that in this industry that we're in, called technology, or I call it the racket of technology, we have the tendency of getting excited every once in a while, right? So there's this phases of excitement. It's very hard to believe now, but about 30 years ago, SQL and relational modeling was a very cool thing that revolutionized data persistence and things like that. And then it suddenly somehow became very uncool, right? It was all about NoSQL and object databases and document databases. Similarly, object-oriented design has really revolutionized the way we write code many, many years ago. And then suddenly all these hipster kids came by and then said functional programming is where it is at, right? The object-oriented programming is not really cool anymore. So there's these phases of things becoming cool, and if you follow this coolness trend for whatever reason, you will see that right now the cool thing is microservices, right? You cannot go to any conference about technology or coding or whatever and not hear about microservices, right? So we felt that this conference needs a microservices talk as well. And because they always throw me under the bus, I was the one that had to talk about microservices, right? So that's what we're going to talk about. And I want to start by why are microservices so important, and why is everybody buzzing about microservices, right? And there are many reasons, but I would say, if you ask me, I would say it's probably the top 3 reasons are on this slide, right? It's really about microservices as an architectural style delivers some of the traits that we really look into technology, right? So it appears that they really help with continuous delivery, right? And we're all about continuous delivery and releasing multiple times a day because that's what cool kids do. It looks like microservices as an architectural style really help with designing your system as an evolvable system, right? The business moves at very fast pace, the requirements change all the time. Currently, microservices help you design those systems that can follow these changing business requirements. And it also appears that microservices are really well aligned with modern software development processes, right? You have to align your architecture with your process, and it appears that microservices are a much better fit with agile development processes than the traditional multi-tier monolithic architecture. So do I have your attention, or you're not interested to hear more? If you don't say yes, I'm gonna walk. Like, I don't care, I'm crazy like that. Like, so yeah? You wanna hear more? Okay, let's do this. So let me start by, so there's a lot of excitement. I just told you why the people are excited about microservices. Let me also give you a definition of what microservices are, right? Who wants to hear the definition of microservices? I'm really getting myself in trouble here, by the way, because there are about 100 different definitions of microservices. The god in this space, who is the god in the space of giving us definitions? Martin? Yeah, thank you. Martin Fowler, right? The guy that we always go to for definitions. He said there is no one definition of microservices, but I'm going to be the brave one and give you the microservices definition. This is how I'm going to define, right? It's basically an architectural style that allows you to decompose a complex system into small components, and you kind of have to have a number of traits that this decomposition follows. And for me, the 3 most important traits are that the services must communicate using language-agnostic APIs, right? It cannot be anything proprietary. The services must be independently deployable. I must be able to deploy one microservice to Amazon and another to Rackspace and another to Google Cloud and declare that I'm so impartial in my hosting. And in order for us to be able to deploy independently, it is very important that we use data decentralization, right? Every microservice has to own the entirety of the data it needs to operate. There is no data sharing. So this is important. And that's the only way we can achieve the independent deployability. And the challenge is, this is easier said than done. right? You will hear a lot of the talks that praise microservices and it can do this for you and that for you. You then actually start doing it, it's not easy. Right? The way we are used to building software, we actually do a lot of data sharing. Right? We have one data model that everybody shares. So this whole decentralized data management can really get you in trouble once you drink the Kool-Aid and start building microservices architecture. So what I want to do here is, because we've kind of been there, done that, and have gone through the pain points, I want to share with you some of the super secret tools and techniques that you can use once you actually decide to build microservices that will help you to actually achieve this data decentralization. You're not allowed, when you leave this room, you're not allowed to tell anybody about it. I'm just kidding. You tell anybody you want, but basically these are some of the things that we have found to be useful. The most important thing, if you want to get this done, is you will have to change your mindset, right? We are, as software engineers, and I'm one of the guilty ones, right? We're used to thinking in terms of data. We're used to thinking in terms of the data design. If you want to do microservices, if you want to build microservices architecture, we have to change our mindset. We have to stop in terms of the data and designing data and the relationships of the data. We have to start thinking in terms of what are the capabilities that our systems exhibit. Because each capability then is a microservice we can implement, right? We have to move away from data-centric thinking. And the kind of formal concept or approach that helps us actually achieve this is this thing called bounded contexts. How many of you have heard of bounded contexts or used bounded contexts? So a fair number of you. Bounded contexts come from this larger kind of approach, which is called domain-driven design, which, as far as I know, or at least that's where I learned it from, was introduced and coined by Eric Evans a while ago. He wrote a book about domain-driven design, and very shortly what this means is that when you're building a large complex application, an enterprise application, there is no one domain model, right? We talk about domain model, but really a complex application is a set of interacting contexts, and each context has its own domain model. And the way we can simplify a large complex application is by identifying this natural context that he calls bounded context. And the reason he calls it bounded context is that he argues that within this bounded context, you have a lot of entities that other contexts don't care about, right? There are natural boundaries in which you can have all these entities, call it objects, classes, data, that is important for implementation of that context, but nobody else needs to know about. If nobody else needs to know about it, then we don't have to share it, right? And our goal is to manage not sharing data. And not only that, so an example of that is, and you'll have to excuse my knowledge in fintech, I'm not a specialist in that, but in my mind, when you're designing a banking application, right, you can have a security context, and you can have the actual financial banking account management context. Is it way off? Anybody's building banking software? Am I totally off? Is it okay? Yeah, thank you. So, what is your name? Sorry? Okay, James said it's okay, right? So if anybody has a problem with it. So, in the security context, we have a number of entities, and I think James would agree with me that only security context needs to know about these ones, right? Sounds reasonable? And then we have other entities in the banking context that make up the functionality, and really only banking context needs to know about it. We also notice that these contexts have some entity that has the same name, right? The specialists in these domains would say that there is an account in the security context, there's an account in the banking context. Right? But the reality is that what they mean in that context is very different. In the security context, account means user password, however you authenticate. In the banking context, account means your checking account or your savings account, right? So just because the names are similar does not mean that they are the same thing, right? So this allows us to identify those organic boundaries, which allows us to kind of isolate the data and avoid data sharing. So if we want to design microservices without data sharing, if we want to have this decentralized data management, we have to really get very friendly with domain-driven design and start our architecture by identifying the bounded context. And then the bounded contexts are kind of, from the business perspective, your capabilities, right? Each microservice is a capability, and this is what Sam Newman, who wrote a fantastic book about microservices, by the way, has to say about it. He says, in your organization, you should be thinking not in terms of data that is shared, but about the capabilities those contexts provide to the rest of the domain, right? So this is through the bounded context identification, through thinking about capabilities, not data, this is how you can achieve the ultimate goal. So this is a very powerful tool, but my goal here is to be very honest with you, right? So I'll tell you the truth that many people will not tell you, which is, this is not an easy thing. Like the whole domain-driven design, identification of bounded context, you have to do it. It's not a walk in the park, right? It takes time. It's not necessarily what software engineers do. It's not necessarily what how many of you have done formal domain-driven design and bounded context identification in your architecture? So a couple hands. So this is not what we necessarily do, right? And it's also a very big subject that there's no way I can cover in this 20 minutes, but I wanted to just name it as something that you will be doing in microservices. And there are some really good books if you want to dive deeper into it. It all started by Eric Evans's book. It's as all first books go. It's a very heavy book, 500 pages, right? So there are, you can feel free to read it, but there's also some later books that are much more approachable that I would highly recommend. Bounded context identification and implementation is a very powerful tool, is an essential part of microservices architecture. It's not the only thing, right? It's not the only tool you will be using. And another tool that you will be using is the two patterns in software architecture that most banking software engineers and architects are already actually familiar with, because a lot of banking software uses it, but it's not necessarily that widespread in other contexts. It's event sourcing and SQRS, right? So for the sake of being complete, let's say what those are. Event sourcing is this pattern when instead of updating the state of an object, right, using CRUD for managing the state of your data, what you do is you create an event store. Right, so every change in the system is a sequence of events which are immutable and basically append only. So let's say I deposited money in my bank. You have an event of depositing money in the bank. You don't just take the account object and update its state. Right, it's a sequence of events. And usually when you do event sourcing, it's tightly coupled with another design pattern called command and query responsibility segregation, which is a very fancy way of saying basically your data changing operations and the storage for data changing should be completely different from your querying, storage, and data model, right? So the way you query data, the way you update data should be separate. So let's see an example of that. And again, I'm not an expert in this field. I'm expert in architecture, not banking, but James will correct me if I make some mistake. So this is how you would use those two patterns for microservices and for banking. Let's say I'm depositing money into my account, right? So the way it will go is I'm probably going to use some message queue to smooth out some possible spikes in operations, do all the good things, and eventually there will be an event of somebody deposited money into my account going into an event store. And we have really nice, highly scalable, append-only systems like Cassandra would be a fantastic way of storing those things, right? But Cassandra is not necessarily the best system to query data, right? It has some limitations because of the optimizations they made. So when I store my event, it can issue then some pub/sub driven event for other microservice, which is query of the accounts microservice, and I can index for query optimized fashion the same information in my store like Elasticsearch that then allows me to see a snapshot of an account on any specific date or whatever you want. Those are very capable indexes, right? And the reason this is important is because if you just do a bounded context analysis for identifying your microservices, right? A lot of your business analysts will tell you that kind of the account management is one context from the business perspective. But you can get further granularity by then splitting that one business context into multiple microservices, where you can have a microservice that manages deposits, you can have a microservice that manages transfers, the microservice that manages getting the money out, and the microservice that manages all kinds of reports and views and other things, right? Yes, sir.
Don't you get into a lot of problems about state? Because the example you are just showing right there would essentially have a problem about when the balance is updated. It's not atomic anymore.
Right. So we'll talk about atomicity and transactions in a second. As far as the state and traceability, event stores actually give you a lot of benefits in being able to see every step that modifies the state. So instead of having this obscure, we now have suddenly $20,000 in my account, and I have no idea where it came from, you can really trace. So for compliance and other things is why actually the the event store was invented, but it just appears that it's very good also for microservices and decentralized data management. Okay, but like you said, once we do all of this, then we have a question of transactions. And transactions are important because when you build any distributed system, this is not just about microservices, but when you build any distributed systems, you run into problems with transactions. And it stems from one basic issue, which is in a distributed system, the only way ACID compliant transactions, right, which is what we think of transactions when we talk about transactions. The only way you can really implement ACID compliant transactions is by implementing locks, right? So I have to put a lock on some record and nobody can touch it while I'm working on it. And if it's a distributed system and the data is decentralized, you just cannot do that. Right? You cannot, the one microservice cannot put a lock in another record which is in the data storage of that microservice, right? So the good news is we have been doing distributed systems way before microservices, and there are some architectural patterns that help us with this. One of my favorites that help you do transactions in a distributed system is called, lovingly, it's called a saga, or more officially, it's called long-lived distributed transactions. How many of you have implemented sagas in your past experience? Okay, so I get to tell you something new. Exciting. So the way I like to explain sagas is by telling you how you would implement like a booking of a travel kind of system, right? This is the context I know a little bit more about than implementing banking software. So I know about this because I do this a lot. I travel a lot, going around giving talks. And usually what I need to do is I need to use our corporate travel system to book everything, right? I, as a employee of a big corporation, cannot just go and book stuff on Expedia or something like that, right? I have to use my corporate system. Oopsie. And the steps that are required are that I usually need a flight, I usually need a hotel, and if the airport is too far from the office, I may also need to drive there, right? So I need three things. It's a workflow, and I kind of need all the steps to happen, right? There's no sense for me getting a hotel if I cannot actually fly there. Usually I don't like sleeping on the streets, so if I get there, I better have somewhere to sleep, right? And I cannot walk too far, so I also need a car if it's far away. So I need three things. Usually those are booked through different systems, right? And as powerful as our travel agents are, they don't actually have magic powers of putting logs in the databases of Marriott or Hilton or American Airlines or United Airlines or any of that, right? So I think we can all safely agree that there is no way my travel agent can put an actual database log in the database system of Hilton, right? That's not gonna happen. But they are able to somehow implement this distributed workflow. So let me explain to you, I don't know how they implement it, but let me explain how you might be able to implement something like that. We could be able to implement that using sagas, and the way it would work is we implement each step of the workflow as a distinct, fully executed transaction, right? So as opposed to ACID transactions where each step gets into this limbo state where they're not really fully committed, and until the whole process finishes, they're in this intermediary state. In this case, each step gets fully committed, but once an agent for each microtransaction commits their part, what they do is they also register something called compensating transaction on this shared trip slip, the thing called trip slip, right? So the car rental microservice will fully book my car, and they will be successful, but they will also say, if down the road some other step fails and you have to roll back this workflow, here is the pointer to the compensating transaction that will reverse what I just did, right? I'm done, I did it fully, but this is what you need to do to reverse it. And like in the case of the car rental, that would be cancel the car rental reservation, right? So this is how sagas or distributed transactions work. They are different from AC transaction. They are different from lock-based transactions. But what they do is that in an eventually consistent system, right, which is in most cases how you implement distributed systems and where the microservices really work, they allow you to create a workflow management tools that effectively work like transactions, right? And there's a link down with where I actually got this example from that I love very much, and you can learn more about this, but this is another tool that you can manage to do transactions. These are really the three major things that you can use to achieve no data sharing in a microservices architecture, right? Yes?
How do we handle the case where you can't undo that? It's in a cash machine and pay out money?
Yeah, so that's exactly why when you design your sagas, you design, so it's a best effort system, right? And when you design your sagas, you leave the riskiest operations at the very end. Like, not all of these operations have the same risk, right? Usually it's very, like, no car rental will charge you anything if you cancel your reservation, right? But air flights, they usually will give you a portion of your reservation or something like that, right? So you want to do those at the end to minimize the risks, right? So there's some strategies managing this.
Isn't the passing back the cancelling transaction that that's effectively sharing, you're sharing data there with a reference to a transaction? But there's state being carried through the steps in order to be able to unlock this transaction.
Not a shared state. It's just a pointer of call this if you need to do that, and that endpoint knows something about it, right?
It's a link to state.
Okay, so.
Sorry, just one question.
Hmm?
So transaction management systems have been around for 40 years.
Hmm?
I mean, how is this any different from transaction management systems?
Transaction management as in ACID compliant transaction management?
Atomic state, I remember stuff that I have rollback capabilities if I have the entire transaction complete, exception conditions, that's all part of the system.
You mean distributed transaction management systems? Right, so they do rely on shared state. They're not really for microservices architecture.
They all, you can have the same, right, the same condition, and you can have state in terms of flags, and I can't have microservices architecture that's spinning up and handling one part of it instead of state. So how is that any different?
Well, I don't know which specific transaction management system you're talking about, but all of the ones that rely on the locking will necessarily have to rely on the shared state, right? So if we want in the microservices no shared state, this is one of the architectural patterns that can help you implement that. There are tools that implement sagas. There are other ways to implement no shared state transaction systems. So if you have a system that allows you to do that, then you can use that as well. Make sense? Okay, so those are the tools, but there's also one last thing that we need to discuss to kind of really wrap up the practicality of microservices management. And it's usually when you talk about the microservices, it's usually the elephant in the room, right? So as soon as you say microservices, that assumes certain size. So I've heard, like, once microservices became popular, I've heard people talk about nanoservices. What if we get even smaller? So the big debate, the big heated debate in microservices is how small is micro? Like, what does microservices mean? And some brave people have even been so courageous that they have started talking about it has to be this number of lines of code, or it has to be something that 2 pizza teams can implement. There's certain guidances in that, and I'm of the opinion that all of them are BS. There is no fast rule for how small your microservice should be, and this is the reason why, right? Microservices are really driven by bounded context, and there is no fast rule for how small or large your bounded context should be. Really depends on your domain, right? So this is what von Werner says. Bounded context should be as big as it needs to be in order to fully express its complete ubiquitous language, right? If it does not capture the whole business capability that it is supposed to capture, then making it any smaller just makes no sense, right? So from the business perspective, it has to be as large as your bounded context is. You can make it a little bit more granular by using CQRS and event sourcing. But that's about it, right? You cannot make it into 200 lines of code if it doesn't fit into that. That said, as we understand the domains better, as we work on things, we start to understand the domains better, we are able to identify more granular bounded context. So you will see that people who actually implement microservices, they will start more coarse-grained, right, until their understanding of domain becomes better. And then increasingly, they will get into more and more granular. So they will start with 10 microservices, then you will see 50, 100, etc. And people who have been doing it for a while report that some of them have found to have reached, like Netflix said, they have 500 microservices, right? So it can get into hundreds of microservices, which raises a problem of its own, which is, well, you kind of have to deploy each microservice on its own isolated unit, right? We made that promise. What is that isolated unit? Maybe a server, maybe a virtual machine. But in either cases, 500 servers or virtual machines on Amazon are not that cheap, right? Amazon is very cost effective, not when you get to 500. And also consider the fact that you will have to deploy those redundantly, right? If one fails, you have to have others survive. So at least in the multiples of 3 is what you normally would do if it's mission critical. So 500 microservices basically means 1,500 either servers or virtual machines. That's not cheap. So how can we even afford this, right? Like, is this some theoretical exercise that only Google and Amazon and Netflix can afford? Can like a startup even do microservices architecture? What is the magic answer, right? And further than how can we afford it, a lot of developers like to have an environment on their own laptop, like the full environment, right? That they can use to develop. So there's no way I can install on this. This is a pretty good machine, right? You didn't go cheap, like this is a powerful, yeah, it's the best. Can you install 1,500 virtual machines on this one? There's no way you can, I can tell you that. So how can Ronnie develop a reasonable microservices architecture on his own machine? How can he afford to put it in production, right? What is the magic? So apparently, we have a magic, and the name of the magic is called containers, right? If you're not familiar with containers, it's a Linux kernel extension, basically, that allows you to get an isolated namespace environment, kind of like virtual machine, but as opposed to virtual machines, it has, for any practical purpose, it has 0 overhead. So Ronnie will have, I promise you, Ronnie, you will have no problem installing 1,500 containers on this machine, but you would not be able to install 1,500 virtual machines. So when you talk about microservices, you will always hear something called Docker mentioned right away, right? Because Docker is this standard image format for containers. It's built on top of the Linux containers, as well as management tools that most people right now use for container management. So containers and microservices go hand in hand. People deploy microservices usually with containers. And I see some angry faces looking at me because I'm running out of time. But hurrah, we're done. Thank you very much.